Hey guys, welcome back to Rocket Gyan, my fellow space tubers. Okay, so here we are to witness another launch, and this one will be from Astra, which was supposed to launch yesterday, but was first of all because of the technical glitch, and then because of the weather, and then simply the launch window ended. We They weren't able to launch. So now we are again here to witness the launch, and hopefully, I'm just hoping that we will get the live stream as per the plan, because that is not what has happened yet. Whenever I have streamed the Astra launch, it has already always been delayed. So let's hope this time we get to see it. Uh, Hi everyone. Hi Ayan. Hi Rubil Islam. Hi Starship Boy. Hi Pawan. Hi Minute Man. And hi Iron Clue Gaming. Oh, Iron Clue Gaming. This must be your birthday today, right? Happy birthday to you. Hopefully you get your kind of a birthday gift as this rocket launches to space. Okay, let me just see once good like it. Okay, fine. Uh, Now let's have a let's just dive into the rocket and what this rocket is all about. So this rocket is a two-stage rocket, and it's you can say extremely small set launcher. Why it is so? Because the payload capacity for this rocket is not like electrons, also like 300 kilograms or 500 kilograms. No, the payload capacity for this version is 50 kilograms only, and 50 kilograms is, you can say, is the extended version, because previously it used to only carry 25 kg to space. That's it. And now, because they have extended the first stage, that's why they're able to carry 50 kilograms. So this stainless steel body, yes, it is stainless steel body, is the first stage, and the second stage is housed in this interstage as well as the payload adapter. Sorry, pairing. Now, talking about this rocket only, we'll just have a quick rundown of this rocket so that everyone can have a feel of it. Okay, so this is this rocket, and you can see here this section is containing five engines, five Delphin engines, I must say, which runs on RP1 and LOX as its fuel, the same fuel which Falcon 9 uses, and this runs on the engine runs on electric pump fed cycle, same cycle which the Electron rocket uses. And you will see this trend coming in very soon and very popular in the rocket industry, when the small set launcher which are having very very less payload capacity, they will use this electric pump fed cycle. Reason: A, because it is very simple to make. B, it does not carry much weight. And C, it just gets your work done. So why not go with that? And obviously these engines, these five Delphin engines, are 3D printed. So that's a plus point, because they are aiming for a day launch. I mean, every day they want to launch a rocket. They are what this is what they are aiming for. So that's why they would require this 3D printing capability, and they are getting that. Now, talking about the second stage is like this only: two balloon looking like fuel tanks. That's it. And engine. And engine, if you see, is also very not much complexity you can see here, because this is a pressure fed engine, does not have any sort of cycle. Okay, so you can see this thing here, and the pressure fed this thing, the second stage produces 3.2 kilonewtons of thrust, the first stage produces 147 kilonewtons of thrust, and it is able to put around 50 kilograms to sun synchronous orbit. This rocket is only capable for polar lock rocket launch. Now we'll have to wait for other thing. I mean, it can launch to low Earth orbit, equatorial also, but right now the launch site is such that it does not allow equatorial launch. Okay, now let's have a look at the timeline of what it is targeting today. So inclination would be 86 degrees today. Altitude will be 500 kilometers. So it is going to low Earth orbit with an inclination of 86 degrees, which means it is a polar orbit, more like a sun synchronous. And the payload which it includes is a non-deployable space force payload, which is you can say a mass simulator or a dummy payload, since it is a test flight, so they are not carrying a actual payload to space. But if this is successful and the next mission is also successful, then we will see that happening also. Okay, so this is the case, and I think that must sum up everything which I have said, and which you wanted, which you had to know before this launch. So we'll switch over to the live stream if it is live. Just a sec, guys. Um, Thank you so much all for joining in. Really, really appreciate you. Why launch from Alaska? Okay, that's a good question. Let me just have the stream here first. Okay. So why launch from Alaska? Because first of all, as they said, nobody's launching from there, so they get their authority to do, the things in their own way, as well as the launch site there is very favorable for polar launches. Okay, and that's why, since it is favorable for polar launches and they are aiming for polar launches, so why not launch from it, right?
Hello everyone, you are looking live at Launch Vehicle 0007 on the pad at the Pacific Spaceport Complex in Kodiak Island, Alaska. Astra is currently at T-minus 42 minutes and counting, and we are anticipating a hold at T-minus 30 minutes for propellant load operations to complete. So we are coming to you live now from Astra's headquarters in Alameda, California. My name is Thomas Burkhart, News Director for NASA Spaceflight. I'm joined by Carolina Grossman, the Director of Product Management at Astra. Carolina, thanks for bringing it on tonight.
Thank you. Very excited to be here for our next launch attempt.
Astra and NASA Spaceflight are partnering once again to bring you this live stream, so thanks to Astra for covering some expenses involved in making that happen. Also, as usual, we will be taking your questions from chat, so if you have a question about today's launch, please tag us with @NASASpaceflight. We're going to bring in those, as many of those as we can, and answer as many as we can over the course of the broadcast. If you were with us last night, you saw that there was a launch attempt that was scrubbed late in the countdown, and we have some more information about that. Carolina, what went on last night?
Yes, so if you were with us last night, we had a scrub at T minus roughly 12 minutes before our T0 time. And unfortunately, last night was very, very cold in Kodiak. It was -8 degrees Celsius or 18 degrees Fahrenheit. And even though over the last couple weeks, as we've been testing our system up in Kodiak, we've learned how to mitigate a lot of the weather issues that we've encountered in these extraordinarily cold conditions. However, last night we did find some frozen moisture in our igniter system that we were unable to clear in time for our planned T0 time. So the team today has reviewed the system and implemented a few mitigations that we believe have resolved the issue. And so far, this evening, the system appears to be working nominally.
Sounds good. Hoping for a smooth countdown and hopefully a launch today. Again, we're expecting a hold at T-minus 30 minutes, which is why that countdown clock is already at T-minus 40, but we're expecting a little bit of a delay later in the countdown, but hoping that will go smoothly and we'll get to a launch sooner rather than later. Carolina, where are we in the countdown right now?
Sure. So as you can see on your screen, you can see that middle portion of the rocket. That's the first stage. Liquid oxygen tank is filling up. It's indicated by the icy condensation starting to form around it, and so we'll continue with our propellant loading operations. Otherwise, we're keeping an eye on the winds tonight, as usual. However, the conditions do look good for our flight tonight.
Sounds good. Again, please bring your questions in the chat. We'll start bringing those in just a second. I want to look back just a couple days because we haven't shown this yet. We have some video of the static fire test, which precedes the launch attempt, happened just a few days ago in Kodiak Island. Let's take a look.
That's cool. That was indeed cool.
So we saw there the water deluge, everything, and the engines tonight. Can you tell me exactly what's all the test objectives for a static fire test?
Sure. So the static fire is essentially our last real full dress rehearsal of the system to make sure everything is working exactly like it will on launch day. The main difference that you see between a static fire test and a launch attempt is that we don't let the engines go. So during a static fire test, we load our propellants exactly as we intend to on launch day. We ignite the engines, we run them for a few seconds to make sure that everything is working fine, and then once we have confirmed that we've obtained the necessary data, then we shut off the engines. And so that test happened earlier this week, and within really a matter of hours, the team was able to reset and prepare for tonight's launch attempt.
And there was something unique about this particular launch campaign in that it happened in Alaska, because that is a little bit different from how it's been done in the past, right?
Yes, that's right. So usually we will complete this static fire test closer to our headquarters here in Alameda. We perform the test out in the Central California Valley, a couple hours from our headquarters. But this time we decided to perform the test up at our launch site, and so we're very grateful for the partnership of the Pacific Spaceport Complex Alaska and the Alaska Aerospace Corporation in working with us to allow us to test in more launch-like conditions, which has been very helpful since these are really cold temperatures that we've been seeing, and over the last couple weeks of working towards our static fire test, we've gotten to learn a lot and iterate very quickly in order to get to this point.
Has that also changed simply since the last launch, which of course was also in Kodiak, but wasn't in November? Is there a big difference there too?
Right. So our last launch was in August with warmer temperatures, and then prior to that we had launched in December of last year with our Rocket 3.2. And those launches both occurred during the daytime. So
Right.
even though the December conditions in Kodiak can also be very cold, these nighttime conditions are some of the coldest that we've experienced with our system to date.
Gotcha. All right, we got some questions coming in from chat, so let's dive into these. First question comes from Tucker, and we're talking about Astra's overall mission, asking what is Astra's ultimate goal with launching a rocket every single day by 2025? What exactly are you launching that it needs to be daily?
Sure. So Astra's mission is to improve life on Earth from space, and we're seeing a lot of really small CubeSats and microsats that want to help observe and connect and help do those kinds of things that Astra's trying to do with its mission. So we see actually a lot of demand for launch from every day, and right now, access to space and launch access is one of the biggest bottlenecks in the industry. So we see that there's a lot more satellites that are projected to be built in the coming years, that we think that there will be demand for launches every single day.
And is that more like, because I think Chris Kemp, he's spoken on NASASpaceflight before, he's spoken on the Meet the Team video. By the way, if you have not seen the Meet the Team video, check it out on the NASA Spaceflight channel. But a lot of them describe it more of like a service. You know, you take a package to UPS or FedEx or something, and you say, I need this to go someplace. They don't schedule a flight right then and there, right? They already have flights scheduled, and it's just a matter of putting payloads on board. Is that kind of what Astra is aiming for?
Yeah, that's right. We want to make it as simple and easy, and I think, right now it can take many months or even years from the time that a satellite wants to get a ride up to space to the time that it can actually make it onto orbit. And so, yeah, we want to make it as easy to send a satellite to orbit as it is to send a package across the country. And I'm really excited for the future that we'll build when that's possible.
It's definitely very interesting. Something very
Great.
different from other spaceflight companies that we look at. So it's interesting to talk about. Let's bring some more questions into chat here. And oh, here we go. Nick from chat asking, where can we buy some of those water bottles or any Astra swag? Got the product placement here on the desk.
Yeah, that's a great question. And right now we do not have a store where you can buy Astra swag. So the only way that you can get some Astra swag is to come join us. You can check out our open positions at astra.com and our careers page there. And we are hiring for a ton of roles across the company. We'll also be looking into an internship program as well. So please make sure to check out our careers page for your own opportunities to get some cool Astra swag.
We get a lot of questions in chat almost every stream about, how to get involved in the industry, how to get jobs at different things. Of course, asking Astra directly through these cool broadcasts. But, it's exciting to see people like that in chat, and glad that we're getting some people excited about space and stuff. I love that stuff. Another question here from the Orc Cloud. I don't know if it's from the actual Orc Cloud, but the question asks, what changes have been made to LV7 to prevent an LV6 from happening again?
That's a great question. So if you watched our LV0006 launch in August, you may have remembered it went a little sideways. It was certainly a unique launch that we had, certainly nothing like I've ever seen before. And what happened is that the propellant system that loads onto the vehicle is designed to quickly seal off and disconnect when the vehicle lifts off. But unfortunately, a very small amount of propellant leaked out of that system, and due to the very, very hot exhaust of the engines, it ignited and caused some of the electronics on one of our 5 first stage Delphin engines to send a signal to shut off one of those 5 engines. And so all of this happened within 1 second of launch. And because we lost one of those engines, the vehicle essentially burned off and lost some of that mass of the propellant and did that cool hover maneuver until it achieved a sufficient thrust to weight ratio to actually lift off. And so the changes that we've made primarily focus on that propellant loading system. And so we've relocated and changed how that system it onboards the propellant onto the rocket to make sure that in the unlikely event that anything should leak, it will be much less likely to mix and cause a similar situation. And more broadly, we looked at how we tested and verified that system and implemented some changes into how we do our component testing and verification more broadly to help prevent these kinds of issues from happening in the future. And I just want to commend the team for working really, really hard. We're talking combing through data by the millisecond and working very, very hard over the course of just a matter of weeks to complete this work and get us back to the pad really quickly.
That's right.
Absolutely. And it is still worth mentioning, though, that this is actually the second rocket 3.3, because there's kind of 2 different naming schemes to talk about. There's the version of the rocket, which even though this LV7 is different from LV6, they're both in the 3.3 classification. Can you tell me what the difference between those 2 schemes are?
Sure. So kind of like a software release version, Rocket 3.3 is like the overall release. We constantly intend to be iterating and making small changes to the vehicle, but those kind of the 3.3 number is really like the class of this rocket, and so there were really substantial changes between the Rocket 3.2 launch in December and this current Rocket 3.3 vehicle. But in essence, we expect the changes from tail number to tail number of this rocket to be pretty similar, and so we'll just continue to refer to them by their tail number without really changing that class or release number
Gotcha.
until we get to sort of our next major iteration of the vehicle.
Gotcha. And so this is the 7th launch vehicle, but the second of Rocket 3.3, that version. And this is Astra's 4th overall orbital launch attempt, again, aiming to demonstrate that orbital capability before moving into customer flights. In the meantime, we have just hit that T-minus 30-minute mark, and as we said, we are expecting them to hold there. So we're in this hold. The teams are currently working to just complete propellant load operations, and once this hold is released, we'll have a new target T0 time and an actual target time for liftoff. So we'll bring that to you as soon as we have it, as the teams continue to work it. In the meantime, we're going to keep the Q&A going here, and again, if you have questions, please tag us at NASASpaceflight in chat. And my first question comes from Tin Man that says, how tall is the rocket and what propellant does it use?
So we will definitely be talking a lot about the specs of our vehicle, but overall our vehicle is 43 feet long from tip to tail, so it fits pretty snugly in a 45-foot shipping container, which helps makes our logistics and transport to the site pretty easy. And as far as the propellants, both stages use a combination of liquid oxygen and RPX, which is essentially kerosene. And so both our first stage powered by the Delphin engines and our upper stage powered by the Ether engine use those propellants.
And to differentiate, because there are a few rockets that use kerosene and liquid oxygen, it's a pretty common mixture of Falcon 9, Atlas 5, to name a few. But those actually usually use an RP1 kerosene, and you're just saying RPX, so that's just a different grade than maybe the other companies use?
Yeah, that's right. It's slightly different from RP1, but we use RPX.
Gotcha. Next question from chat that says, at T-minus 2 minutes and counting, does the flight computer take over the countdown? Where does that occur?
Yeah, so one of my I think most exciting moments of the countdown is hearing it's at T-minus 60 seconds. The call from our flight director will be that the vehicle is on internal control. And at that point, at T-minus 60 seconds, that's when the internal systems are now in command of the vehicle, and they'll continue to command the vehicle through flight. So there's no human input into the system during a nominal flight, where our guidance algorithms and our flight software algorithms are in control of our rocket.
And as we get
Great.
farther into the countdown, we'll definitely highlight and explain some of those things as they happen, as of course that's a later in the countdown issue. But we're going to keep them coming here. Next question from chat says, will there be any other versions of this rocket?
Well, certainly for tonight, we are focused on the launch of LV0007. And as we mentioned a little earlier, our goal is to reach daily space delivery and offer a rocket launch every day. So Astra has many future plans. You can learn more about them by following us on Twitter or checking out our website, astra.com. And as a public company, we also provide a lot of future information in our SEC filings. But for tonight, we'll be focused on LV0007 and our mission to reach orbit.
All right. Speaking of reaching orbit, I got a question here from Avenger asking, why fly from Kodiak when it is harder to reach orbit because it's so far away from the equator?
Yeah, that's a wonderful question. So first of all, I just want to shout out our wonderful partners at the Pacific Spaceport Complex, Alaska, and we really enjoy working with them. I'm very glad to have launched out of there, and we'll continue to launch out of Kodiak in the future. Really, the choice of the launch site is partially determined by the mission. So tonight's mission for the Space Force is heading to an inclination of 86 degrees, which is a favorable location to reach from Kodiak. Kodiak is great for reaching polar and high inclination orbits, which are common for Earth observation missions. And otherwise, launching from the equator is typically very common because that's where Earth's rotation is the fastest, so you get a boost that helps rockets reach orbit. But there are many different reasons for selecting a launch site, and in this case, launching from Kodiak is actually very favorable for the mission.
Yeah, from the physics perspective, you can actually say that when you're launching to a near polar orbit, a high inclination orbit like this mission, it actually hurts you to be close to the equator because you don't want that velocity. So before getting too much into orbital mechanics, I don't want to make this a physics lecture or anything, but it's all about what orbit you're going to, and it's very interesting.
That's right. And I think just to quickly highlight a few other things that are great about launching out of Kodiak is it's a little hard to see right now, but during the daytime you would see, we have a beautiful view, and this launch pad is right on the ocean. So launching over the water makes it obviously easy to keep away from populated areas. We work with the Coast Guard and FAA to make sure that there's no boats or planes in the vicinity, and ensure safety is our top priority. But the location near the water is also makes Kodiak a great choice for launches.
Yeah, you can't see the ocean in this particular camera view, but you can see the lack of lights around the launch complex, which means there's nothing else out there. You got plenty of room to yourself. There's a map of the actual launch trajectory, like the hazard zones that go around the planned trajectory for this launch. So you can see flying south from Alaska towards a near polar orbit, and you got all that room and all that ocean out there to make sure that the launch is conducted safely. And that's, of course, very common for launch sites. Most launch sites launch over water or over uninhabited desert. That is the safest way to ensure that falling stages or any mishaps during launch do not affect public safety, and that's very common. The next question, are there any advantages to launching at night?
Yeah, so the choice of our launch window is really determined by working with the FAA and make sure that we're minimizing the impact to air travel and marine traffic. So due to Kodiak's proximity to Anchorage, Alaska, which is a very, very busy airport, and our upcoming busy holiday season for shipping, the night window was determined to be the option that we had for this mission. Some other reasons for the choice of a launch window may be due to the specific objectives of the satellite, or the precise orbit where the payload is seeking relative to the position of other satellites already in orbit, and of course being able to avoid other objects on orbit, such as the International Space Station. Actually, in this case, one advantage of launching at night is you actually get a really great view on a clear night. I think the rocket plume and the makes a beautiful and very visible streak across the sky. So hopefully folks who are within range of that trajectory to be able to see it visually will have a great view this evening.
Yeah, I do have one question from Jaddy from Mason asking if it would be visible from North Carolina. Probably too far away there, right?
That's probably a little too far, although you'll get a great view from watching our live stream.
That's true. That's the best view, right?
Front row seat.
Gotcha. In the meantime, again, if you have more questions, please tag us with @NASASpaceflight in chat. We're going to keep bringing those in over the course of the broadcast. We also have some other cool stuff to show you. We actually have a little bit more from our NSF factory tour to show out, some bits about how they weld this rocket together and some cool manufacturing stuff. So let's look at that really quick.
So this is what we call our circumferential TIG welder. Essentially what happens on this machine is we'll bring a dome in here, we'll chuck up a dome, and we'll add a barrel section. And this machine is automated. You basically tell it which weld you're running. It positions everything for you, lights the torch, and it'll zip a weld all the way around the circumference. And we just keep adding barrels until we close out and add domes. We basically just grow a first stage tank on this machine.
Okay. And I know the stages on Rocket 3 and going forward are going to be being stretched a little bit, right? Are there changes to the barrel sections and the domes that need to have to that, or is it simple as let's just add more barrel sections?
From a high level, basically it's as simple as add more barrel sections. We had package protected for a longer rocket with extra rails on this machine in particular. And there's a limit to how much you can do there, because you need to start optimizing around buckling stability of your tanks, and what pressure you operate the tanks at, and you end up with a bunch of different trades as you change the aspect ratio of the rocket, and the skin thickness and whatnot. So, but we package protected early on enough that was not a difficult change for us to accommodate.
Gotcha.
So our tanks use two different weld processes. We do friction stir welding for longitudinal seams that go up the raceway, or the raceway axis, and then we use TIG for the circumferential seam. So if you're up on your pressure vessel math, you'll know that hoop stress is exactly double the axial stress of a cylindrical pressure vessel. So you need double the weld performance on that linear seam.
Right.
So we use a friction stir weld there that has really high weld performance, greater than 80% paramaterial strength coming out of that weld. And then we use a TIG weld for where we don't need it, which is roughly 50% paramaterial strength, right, order of magnitude.
And are there benefits to doing that and just not doing friction stir welding everywhere?
Yeah, friction stir weld is actually super complicated to do circumferentially. It's actually quite simple to do linearly, right? So we do friction stir welding where it's easy and simple, and then we do TIG welding where we don't need the complicated process. So we do that TIG on the circumferential seam because it's a very, very well-developed process, super easy. We don't need any reaction anvils on the inside of the
This
friction stir
actually
welder.
looks cool.
No crazy stuff going on here, just pretty simple methods.
Gotcha.
Keep it
So we have
simple,
one
man.
of our
That's how
values
you
here at
make
Astra is
rockets.
Simple scales.
Right.
So we try to choose the simple way to problem solve. For me, if you're solving a problem and it looks complicated, you should be asking yourself a question about, am I solving the wrong problem? And can I look at this in another way that actually makes the answer simple? It's a common thing that you're taught when you're going through engineering school, that there are many ways to go about answering problems, and some are much simpler fundamentally than others if you take the right approach. So we definitely try to choose wisely when we're going to apply the right technique.
Okay.
Okay, so let's take some questions right now. So
Again, super cool to get a tour of the factory
Okay.
here at Astra, and if you want the full version of that, please check it out on NASASpaceflight's YouTube channel. In the meantime, we're still in that T-minus 30-minute hold, but I've got a new guest here. Chloe Song is an embedded software engineer here at Astra. Chloe, thanks so much for taking some time to join me today.
Yeah, thank you so much for having me. It's a really exciting time to be here.
Absolutely. You're just going to talk about what is your job and your responsibilities here at Astra as an embedded software engineer?
Yeah, so like you mentioned, I'm an embedded software engineer on the Avionics software team. And our responsibilities are to develop and test the flight software that go on the rocket. So things like our guidance computer, our GPS, our radios, anything with a microcontroller on it, really, we're developing that code. And another big part of what we do is to test that and validate the software changes that we make. So we have what we call a hardware-in-the-loop simulator, our mock-it. And that's really cool because it contains all of the avionics, our harnessing, a lot of sensor simulation, GPS simulation, all that. So it basically acts like a rocket that's flying. So anytime we do make a software change, we can then validate that and run like a full mission simulation and make sure that the expected outcome does actually happen and we can catch any bugs in the software.
Wow, that's very extensive. That's a lot of stuff there. What
See,
part of that is your favorite part of what you're doing here at Astra?
Well, I mean, it's the cool thing about Astra is that no matter what you work on or touch, right, it's either going to go on the rocket or it's going to help us launch. So you really have an opportunity to make such a big impact here, and as an engineer, that's always really exciting to me. So yeah, I think just knowing that I'm writing software for the rocket and it's gonna fly. I mean, that's really cool.
That is
and
really cool.
software is
The
like
whole
taken as a very is ignored or when we talk about rockets. We always talk about the hardware factor and not the software factor, but in reality the thing which is controlling that rocket and which is making that rocket to go to the orbit is its brain, which is actually the software. And there are many cases wherein the software actually caused the issue with the rocket, which can be avoided very much if you have done proper simulations.
So with printed circuit boards, for example, where you place a connector on a PCB can actually affect what the enclosure design looks like. And the enclosure design can affect how the sub-assemblies team is putting stuff together. And even down to like integration when we're putting something on the rocket, if something's like really difficult to put on there, that can be a big time sink for us. So any time savings with manufacturing and installation that we can make, we're constantly thinking about that.
Interesting. And that must be really involved with the testing process too, and iterating from that perspective. What does that testing process look like for the electronics?
Right. So we sort of go through two test processes. One is qualification, and the second is acceptance testing.
Right.
So the first is qualification testing, and when you have a new design, you have to verify that that's going to survive a launch, right? You can't just put a board on the rocket and expect it to, go through all that vibration and thermal cycling and work. So we actually have a lot of that test equipment in-house. So we do vibration testing, thermal testing. We have a thermal vacuum chamber that we use, and that gives us confidence that our products will survive a launch. And so after that, once you have a qualified design, you go into acceptance testing and production. So when we do get a batch of circuit boards back, we can't just put that on the rocket either. You sort of have to verify and do like a baseline functional testing and make sure that you're measuring the right voltages, your communication buses are all working at full speed, things like that. And that's sort of the last gate before delivering a flight-ready unit to the rocket.
Gotcha. And then I always like to ask about the human side of things. We talked a lot about hardware and software, of course, with the avionics team, but the human element is something that I think is really exciting to just learn about here at Astra. You got a lot of different backgrounds and things. What kind of roles make up the avionics team here?
Yeah, we have a bunch of roles. There are more embedded software engineers like myself. We have an awesome group of electrical engineers, GNC engineers who are basically celebrities after the last launch. But we're also hiring. We're hiring for experienced RF engineers, antenna engineers, avionics.
The rocket is like rocket science is like the culmination of every stream that you can have. So no matter what type of engineering you are doing, you are eligible to work in the rocket and space industry. So always remember that. It does not mean that if you have just done that aerospace engineering, you'll be able to work in that. No, that's not how it works. Even civil engineers work
growing,
here.
and that's super cool to learn about and hear about. So, Chloe, thank you so much for taking some time to do some question and Q&A with us, and good luck with the launch tonight.
Thank you so much. Thank you for having me.
In the meantime, we're still in this hold at T-minus 30 minutes. Again, teams are working on completing propellant load operations. We'll have more information and hopefully a new T0 before too long, and we'll share that as soon as we have it. In the meantime, let's go ahead and listen into the countdown net and the microphones out at the pad as we wait for this hold to clear.
Okay, so finally we got to know some great information and insights of this Astra rocket company, which was very cool indeed. So let's take up some questions now. So Mike Hammond says, what is the lowest allowable launch temperature? See, um, when last time we tried to launch at -8 degrees Celsius, which the previous day, it wasn't able to launch. They had to scrub it because there was, as she said, some ice in the fuel lines, if I am not wrong. That's what she said. Okay. So you can say -8 degrees Celsius is not where where you will launch this rocket from. So usually the temperature is not a problem when you launch rockets. Maybe they have to just do some changes in their fuel lines or how the things go inside the fuel line so that these frosting and ice forming does not happen. So I don't think so that's a big problem for them, and they will when they are in the launch business and launching frequently, they will keep this in mind and change their rocket accordingly, because this thing cannot hold them back. Okay, so there are two time zone times. Yeah, there were two times because there was inbuilt time hold for the propellant loading, which is still in T-30 and holding. So we'll have to wait for them to release that. So will Astra be doing monthly launches from next year? Will it be from Florida? Well, that's a great question. I would say Astra is a company which has been made to launch daily, not even monthly, daily. That's why it is having such a low payload capacity of around 50 kilograms. Maybe in the future they may increase it to 100 or 150, but not more than 200. So because of that, since they are having such a low capacity, the rocket is very easy to make, and you can say it is very rapid also. So therefore, they can afford to have like daily launches, and you can say the Uber to space. right? Whenever there will be like flights, like we have flights scheduled in for in the airport, and we just go and buy a ticket, right? That's what they want to do. They don't want like we have to wait, the payload have to wait for the rocket, right? They want to change that philosophy from rocket has to wait uh, for payload, like airports, in airports airplanes have to wait for us. Similar to that, rockets will have to wait for the payload. So every day there will be a rocket scheduled, and then you just have to buy a ticket for them, and then it will launch. So that's how they are planning to do. And obviously this is a need of the hour, with the advancement in the technology and the cost which has tremendously come down when it comes to satellite business. So yes, many companies are joining in for harness the space resources. Few Okay, so why is the launch window at night for a dummy payload? Why is there a window? Yeah, that's a great question. So this is a thing which they have done because first of all, this launch window has been given by FAA, and they said this is a holiday season, and when this is just a dummy payload, so there was obviously not a problem with the window, and this was just a dummy season, sorry, a holiday season,
Back
so
again. We're still in the
it
midst
was
of
a
the
kind
launch
of a
video.
busy
Focus group is
one.
still working that. Of course, they're working on backroom nets and stuff. So the countdown net's actually been pretty quiet. We got those microphones out of the pad, but no countdown chat, right? Countdown
Okay, so
net
let me
chatter.
just complete that. So therefore they don't want to interfere with the public transport and all those things, so that's why they have given the launch window for the night when the airport and air traffic and as well as marine traffic is not very busy.
Sure. So last night after our scrub, we first removed detanked all of the propellants from the vehicle. We bring the vehicle down. That's one of the first steps in our countdown procedure, is to lift the vehicle vertical. So we bring the vehicle down. We conduct any inspections. We review any items that came up during the launch attempt. So again, in the case of last night's scrub, the issue with the igniter system, came up with a mitigation plan for that, and implement that fix, and get a good night's sleep and go again.
The sleep is very important, of course. Next question from chat. Ernest asking why the launch suppression, the water system, sprays away from the rocket during launch.
Yeah, so what's most visible is the outward plume, but we actually do also have part of the system that sprays in towards the system. During the water deluge, we mostly want to make sure that we don't get any fire or anything on the ground. We don't want to get water into our systems immediately in the seconds before launch. But in the event that there is a fire in the launcher, we do have a portion of that system that is directed directly at the launcher as well.
Got it. Next question from Tara saying, does Astra have any dedicated launch photographers? Definitely my dream job right there. Sorry, that was from Josh, so thank you, Josh. I believe I can actually take that one because a couple of friends that you may have heard of on NASA Spaceflight broadcast before have done some photography with Astra. Our good friends John Krause, our good friend Brady Keniston. If you're familiar with NSF's coverage, you've seen their names before. We've seen them out there in Kodiak, so some familiar faces and some familiar names with the launch photography here. Next question, Zach is asking, is there a flight termination system on the rocket?
Yeah, so we do have a flight termination system on the rocket. We'll go through our mission control operators, and one of those folks, Lucas Hunley, is our flight safety system operator, and making sure that if in the event that the vehicle is going off course, we can make sure that there's no bad outcome. So that is, we do have a flight termination system on the vehicle. In our case, it commands the first stage engines to shut down the vehicle and end the flight.
And that's different because some FTS systems are more destructive. They actually terminate the rocket by blowing it up, basically, versus thrust termination.
Right. So because our vehicle is so small, we don't need to use that more explosive system. We can instead command the vehicle to shut down the engines, and we ensure that this is done within our trajectory, within our safe zone. So there should be, everything should be clear in the event that the flight needs to end early.
Yeah. Next question from chat. Question, how
Okay,
much
that's
time does
great.
it take to roll out the rocket and set up on the launch pad?
Yeah, so we can set up a launch pad in a number of days. We ship, this is a great view of our launch pad. You can see one of the shipping containers sort of near the bottom of your screen. But pretty much everything that you see in front of you, except for the large tent and the fence and some of the fixed infrastructure there, does fit in standard shipping containers and goes over trucks and boats and occasionally even aircraft to make it to the launch site. And our red team was a team of a handful of folks that that accompany the rocket and the ground support equipment to our launch site. Will set up the launch pad in a matter of days.
Next question, let's see. What things do you need to take with you to the launch pad? So, relevant question there.
Yeah, great related question. So we bring pretty much everything that you see with us. We bring, of course, the rocket, the launcher that you see, which is the black launch mount sitting underneath the rocket, and the long arm, that's the strong back. We bring those with us. We also bring containers which help us pump the propellant through the system, and we bring pretty much everything we need. So we pride ourselves on having a fully mobile system, and really all we need at a launch site is a concrete pad and an internet connection, and we can set up a spaceport.
Very cool. Next question here. How high will the orbit be tonight? So what orbit are we targeting tonight?
Yeah, maybe we can talk a little bit more generally about the mission objectives, but we are heading for an orbit of 500 kilometers and an inclination of 86 degrees. The payload we have on board LV0007 is a mass simulator for the United States Space Force, and that camera view will show these lights will light up as we send a signal to simulate payload deployment. Again, because the payload is a mass simulator, we will not actually be deploying it. And this is the United States Space Force second mission, STP-2782, which is intended to demonstrate Astra's ability to deliver for the Department of Defense.
Gotcha. And this is more or less a kind of a redo of the previous launches M2, just aiming to demonstrate that orbital capability with a mass simulator on board.
Right, that's right. Our main goal tonight is to reach orbit.
Gotcha. Next question, let's see. How visible will the Aurora be during stage separation? Maybe talking about the rocket exhaust there, or maybe Aurora? I don't know. What do you think?
I don't know, but that's a wonderful question, and I personally think it would be really cool to see the Aurora during tonight's flight. I can tell you, and with our 3.2 launch in December of 2020, we were all so focused on seeing that beautiful ignition of the upper stage engine and watching those milestones that I don't think we would have noticed the Aurora.
Sure.
But it might make for a cool view tonight. We'll just have to wait and see.
And speaking of the cool views, I've got another question, Chad, and I'm going to tee up Michael Baylor for this one. Will there be any cameras on board the rocket for this launch? I think we caught a glimpse of one with the fairing earlier. Right now we've got a bit of a fogged out view from one of the first stage cameras looking down the side of the rocket, but there they are, hopefully looking to come back to those views once the rocket is flying through the air, hopefully later tonight. There's one from the upper stage. That's the upper stage still sitting in that payload fairing, and that's a little bit different for Astra's rocket, right? That stage actually sits in the payload fairing with the payload.
That's right. A large portion of the upper stage is encapsulated by the fairing.
And there's another view. Oh, that's looking down the second stage, right? That's like the second stage, bottom of the tank and the nozzle, right?
Oh yeah, I think I see that it's kind of a dark curve shape in the middle. That would be the nozzle extension of our upper stage ether engine.
Shout out to Mr. Michael Baylor showing off the onboard camera views there. The next question in chat, what fuel does the second stage use and what engine?
Yeah, so both of our stages use the same propellants, which is liquid oxygen and RPX, which is essentially kerosene. And our second stage engine that we were just talking about is, we call it Ether. It's designed and built and tested all in-house, just like our first stage engines. The Ether engine produces 740 pounds of thrust, and it is a pressure-fed engine. So our first stage engines are electric pump-fed engines. Ether is a pressure-fed engine.
The next question here asking, what does their flight software testing process look like?
Sure. Well, I think Chloe, our embedded software engineer, talked a little bit about the testing process during her interview, but I'll just recap some of the things that we do. We have a simulator that we call the Mocket that we use for a lot of our simulations.
Great name, by the way.
Yes, it's a pretty good one. So the Mocket, it's pretty cool. It's all of our avionics and our harnesses and everything sort of laid out to really simulate all of our systems in a pretty robust way. And we're constantly testing and updating things. We do a lot of automated testing, and we are of course, getting the latest wind information during our countdown, and we run simulations and incorporate that data into our latest and greatest flight trajectory immediately before launch as well.
Gotcha. Another question from chat. Again, if you have questions, please tag us with @NASASpaceflight and keep bringing those in. We're going to keep asking them. And the next one asking, what is Astra's current production rate?
Sure. This was actually a similar question that we had from the Alameda Boys and Girls Club yesterday about how long it takes us to manufacture the rocket. So we just want to shout out to the kids at the Boys and Girls Club down the street from our headquarters here in Alameda. And right now it takes us a few months to build each vehicle, and we're gradually ramping up and working towards that goal of delivering a rocket every single day. Of course, it may not necessarily mean we build a rocket in a day, but have the capacity to deliver a completed launch vehicle on a daily basis in the future. So we use, this is some of the ways that we stand out from the competition, I think, is using simple materials, using tried and true processes, using as much automation as we can in our systems, to simplify and really stand out as working towards building to scale.
Gotcha. Again, if you're just joining us, we are still in a T-minus 30-minute hold right now. The teams are currently working through finishing propellant loading operations, but I think we can take that opportunity to actually look at the different roles in Mission Control. Here is actually a view of Mission Control here in Alameda, California. And Carolina, can you talk us through who we're looking at and what all their jobs are?
Yes. So we will start with Chris Hoffman, who is our flight director. He is responsible for overseeing and directing launch vehicle operations per the countdown manual, with the authority to call, hold, recycle, or abort as required. And as a fun fact, Chris Hoffman also runs Rocket Cat Rescue on the side. So if you're looking to help some kitties in need, check that out. To his left, with the Google eyes on his console, is Thomas Arand, who's our Flight Activities Officer, or FAO, and so he's responsible for documenting all of our operations as they happen and making a note of any future after items that need to occur after the fact. Continuing clockwise, we have Chris May, who is Command and Data Handling, or CDH, and he monitors and adjusts state machines as needed under command from the flight director. Then Joshua Green is our vehicle controller with the call sign of Tango, so you'll hear a lot of him as we listen into the countdown net. He operates the terminal controlling the vehicle systems under the direction of the flight director. Then Dan Wilson, GNC and trajectory, or the call sign GNC. He ensures weather and wind trajectory information is up to date, properly loaded, and meets flight criteria, and also wears really great sweaters.
He also has the joystick on his desk, which is, of course, very important.
Yes, the very important joystick that doesn't actually do anything, but is very important. And then Lucas Hunley, flight safety, or call sign FTS. So he's responsible for making sure that the vehicle is on the trajectory and calling the flight safety system should it not be following its planned path.
Gotcha. And so those are most of the call signs that we'll hear on the countdown now, though there are also a few others, right?
That's right. So our mission control, as you can see, is a very small group of folks, but you may hear other call signs as we got into the go and no-go polls, and those are our what we call the engineering back room, which are the engineers who are responsible for the different systems on the rocket. So ACE is our ground software system, INCO is our radio system, Odin is flight software, Delphin is our first stage engine, Ether is our upper stage engine, Booster is the first stage system, Orbit is the upper stage system, Launcher is in charge of the ground support equipment, and Panther is the backroom coordinator. So you may hear those call signs as we continue to listen to the countdown, and you'll hear those during the go, no-go poll as well.
And on top of all of those folks who are working here in Alameda, we also got the skeleton crew that's out there in Alaska, and we mentioned them earlier about the Red Team doing their work. Can you talk a little bit about what the heck the Red Team is?
Yes, our huge shout out to Red Team, who is out there in these cold conditions, making sure that our vehicle and systems are go for flight. So starting off with our Red lead is Adam Frisch, who is responsible for all the activities and the safety of launch pad related operations. Then we have a few pad technicians who are Hill Hudson, Robert Freeman, Eric Larson, and Sam Hirschap. They operate the hardware hands-on on the ground before the remote systems take over, so they're the ones who are making sure that everything's set up. We have our IT, or Red Wire, who's Eric Steinberg. We call him Steiny.
Yeah.
And so he's the specialist in our IT systems and AV, and we have to be very thankful to him for the great broadcast that we're having this evening as well. And finally, our safety lead is Ryan Hirschfeld, who's responsible for the safety of overall launch operation events, including personnel compliance with our safety policies and procedures, which is really important. So again, want to give a huge shout out to our Red Team who are out there in the cold and dark.
Yeah.
We are very grateful for the hard work that you do.
Absolutely. A very cool team out there, and it's cool to see them work. In the meantime, those teams are still working a hold. We're at T-minus 30 minutes and holding. Propellant loading is just finishing up still, and the teams are working on that. As soon as we have a new T0, I will share that with you as soon as we can. But in the meantime, let's go ahead and listen into the pad mics as the rocket sits there and gets fueled up, and we'll bring you some more information as soon as we have it.
Very cool. So here we are. So I guess this T-minus 30-minute hold is our propellant load now. What happened? The propellant load hold is done. I think there is some other glitch or other checklist which they are going on right now. So we'll have to wait. Okay, let's head on to the questions. I answered, why is there a launch window? Is the rocket, are they working on a reusable rocket? Malcolm says. So I would say any company which happens to be in rocket business right now or will be coming into rocket business in future is thinking about reusability, because they know without reusability they would not survive much. So therefore Astra is also thinking about reusability, but right now they are more inclined to for daily launches. Okay, and after daily launches, or you can say if they get their production line close to daily launches, then they can think of usability also. As you can see, the first stage is kind of made of stainless steel, which enables them to basically just splash down or parachute down the first stage, right? It won't be very harsh to the first stage. It's a stainless steel rocket body. So yeah, just like Starship. Okay, so next one we have, how come no American aerospace startup companies build a solid rocket motor? Well, that's a very good question. That is a thing which I wonder also, because uh, mm, liquid fuel for a small sat launcher is very, expensive. If they want to scale up in the future, then that's a different thing. But if they are into rocket launch business, and that too in a small set industry, I think we would prefer a solid rocket motor. Is there any regulatory issue or what? I don't know. Or maybe they just think like, it would be much easier for us to develop these things, and it would be easier for us to handle these things, because solid motor fuel is actually toxic in nature. So maybe that's the case. Yes, they are still trying to get it off the ground, unknown user. And would it help if we got American Airlines to give them a boost? Well, they don't need that right now, but this American Airlines thing is kind of being talked about in the Virgin Orbit, because they literally, the Virgin Orbit rocket literally goes into space by launching from a airline only, a Boeing airline. So yeah, that must have answered your question. Okay, he says, I make a mean sandwich. Is there a job for me in the rocket industry? Well, uh, in the rocket industry, people work and people have to eat. So obviously, there will be some requirement for you too. You can set up a shop at NASA, or how does it work? I don't know. But yeah, obviously, there will be a need for food people. The gates are open. Yes, they have actually. If you see closely now, that they actually have made this opening of the gates from all four sides, which was not the case before. So yeah, they are now making sure everything goes as per the plan. So how much more time to launch? See, uh, we got to know that at T minus 30 minutes there will be an inbuilt hold for the propellant load, but I don't think so. There, what should I say? This hold which you are right now seeing is because of the propellant. We'll have to wait and see how the things will look like. Because you can see the liquid oxygen tank, at least that is full. We can see a proper frost forming in the liquid oxygen
And
tank.
again, we are
So
still
yeah.
holding at T minus 30 minutes and holding. However, we are getting close to resuming that count. And
Okay,
once we
that's a
have the
good
firm new
news.
T0, we'll go ahead and share that with you. We'll do a little bit more Q&A, but once the countdown resumes, the countdown is going to get pretty chatty, and we'll go ahead and listen into that because that's always cool. But again, getting close to resuming the hold. Once we have a new T0, I'll share that. In the meantime, let's go ahead and do some more Q&A here. The next one, let's see. How does fuel get into the rocket?
Sure. So you see that the fuel is pumped into the rocket through our launcher system and the ground support equipment that goes with it. So you may be able to see some of the long hoses on the ground. You can see that this black sort of support structure that the rocket is sitting on, that's our launcher, and it's actually a really complex piece of equipment. You can also see the lines that connect the upper stage to the strong back, that long arm that is leaned back, and so that is those are some of the lines that pump the propellants into the vehicle.
Next question here. Let's see. Shannon in chat says, we're all familiar with the wildlife that Florida fondly calls KSC security. There are gators out there, of course. What sorts of wild visitors do you get in Kodiak?
Yeah, so there certainly are bears out there. I don't think we've seen any recently, but I think the red team in the past has seen plenty of deer and moose and things like that. And during this launch campaign, there's been a friendly little fox that has been roaming around as well, which has been a nice thing to see. But of course, we work with the range and make sure that things are as clear as possible and as safe as possible before we begin our launch operations.
The next question from chat says, what is the latest time, that Astra can launch in today's launch window?
Sure. So we do have about 2.5 hours remaining in our window. Our window closes at midnight Pacific time, so we actually have plenty of time in our window remaining for launch tonight.
Yeah, and again, if you're just joining us, we're still at T-minus 30 minutes and holding, and we're waiting for a new T0, but hopefully getting close to that information being with us here. The next question from chat, though, in the meantime, Kenny asks, or is Astra going to deorbit the payload?
Right. So today's flight is a test mission. So the payload that we have is actually just a mass simulator. So it will not be deployed during this mission. So there will not be any need to deorbit it. The first stage will deorbit, will burn up in the atmosphere with the payload attached to it. We will be sending a signal to simulate the deployment and make sure that everything would have worked nominally had we had a non-mass simulator payload aboard the rocket today.
So just to clarify, the upper stage and the payload still attached will both destructively re-enter safely and mitigate, no space debris and things like that.
Right, exactly. Okay. We consider that to be very important. We want to be responsible stewards of space, and our mission is to improve life on Earth from space, and one of the ways that we think is important to do that is by making sure that we use space responsibly and aren't creating a bunch of space debris.
Gotcha. Absolutely. The next question from Quinn asking, will Astra ever have a need for civil engineers?
Astra has needs for all kinds of engineers. I think that's one of the most exciting things about working here, and one of the things that makes us unique.
As
is
I said,
we have folks from all sorts
every
of
engineering domain
different,
is needed in rocket industry.
And we have, a lot of obviously specialists in aerospace engineering and propulsion, but many of our team come from automotive backgrounds, from different startups and companies around the Bay Area where we're located. I myself have a biomedical engineering background, so you can check out our careers page on astra.com and see the types of opportunities we are hiring.
So for civil engineers, actually, main work for them would be maintaining the launch site, as well as any this ground supporting equipment. Basically, they will work as in a ground team to make sure everything works as per the plan. So yeah, civil engineers are also required.
Working on the design of the vehicle and designing all of the components. The production team is responsible for building the rocket and taking those designs and making them into a reality. And then we have an in-house machine shop, which is sort of part of our production team. And a lot of what you see on our vehicle and on our launch system does come into our factory as raw material, as sheets of metal, and our in-house machine shop turns them into the finished product that you see today. And all of these teams work very closely together. We're all trying to build for scale from the outset, and so it's very important for our engineering team to consider, how are we going to make not just one of this part, but how are we going to make tens and hundreds of this part so that we can scale up our production.
The next question from chat says, can a manual abort be issued when it is under 10 seconds from liftoff?
Yeah, so an abort can be called at any point in the countdown, and so I've mentioned earlier that the vehicle's is on its internal control in those final seconds leading up to launch, but an abort can be called at any point, and the system can also use its own sensors and checks to abort immediately before launch. So there's always a way to hold off and to stop the process as well.
Gotcha. Again, if you have any questions about the launch, what you're seeing, what we're talking about, please go ahead and throw those in the chat. And if you tag us with @NASASpaceflight, we'll be able to see them, and we'll bring them in, and we're going to keep asking those over the course of the broadcast. We are still waiting for this hold to clear, hopefully getting there soon. We're at T-minus 30 minutes in holding. Once that hold is released, we should have a new T0 for you, the targeted liftoff time, and as soon as we have that, we'll share it. But in the meantime, teams are still holding, and we'll have a new T0. Like Carolina said, the launch window extends another hour and a half or so. I'm sorry, 2.5 hours. I can't do math in my head. My apologies. 2.5 hours.
Yes, we have quite some time remaining.
The next question from Sam says, how will Astra manage countdowns and launch? Sorry, let me rephrase that. Okay, we're just getting word. Sorry, getting interrupted because we have new news. We're getting ready to resume the countdown. A new T0 on the way, 0534 UTC. So it looks like we should resume the count in just about a minute. Let's go ahead and listen into the countdown, Ed, as that occurs.
Okay, so let me just change the
This
time.
is flight on countdown. Astra is resuming count at this time. Per step 106, FTS verify mission data load values are ready to be loaded onto the AFTU. Run CAS software as required.
CAS software is running. AFT is agreeing.
Safety, confirm that you have all Astra employees and guests in Kodiak accounted for.
Safety can confirm.
And all personnel are in a safe location.
Correct, you have 2 individuals at AMC.
GNC, verify for me we are still green on COLAs with a 6:04 time and still green on blackout avoidance.
Confirmed, green on colas and blackout avoidance.
RCO, flight on countdown. At this time, Astra requests power on transmitter and enable tone A.
This is RCO, that's INWORT. Flight, this is RCO. We have carrier up and monitor up.
Copy that. Safety, verify signal strength and good power up.
Safety can confirm.
Tango and AV1 rocket support cart, please enable the FTS.
FTS is enabled.
Safety, verify FTS is enabled and nominal.
Safety can confirm.
RCO, flight on countdown. At this time, Astra FTS is enabled on the vehicle.
RCO copies.
This takes us to final software load. Tango in machine pump battery 2, manage pump battery charging. Please set us to mode 2, stop charging pump batteries.
Mode 2, charging is stopped.
In AV1 manage power systems, toggle off guidance power system authority.
Guidance power system authority, off.
In AV1 manage polling, toggle do only ground polling.
Do only ground polling, on.
Per step 120,
Version.
5 Victor 137, GNC Kodiak launch config. Successful load.
alright, Tango in VB1 turn on off PDBs, please run a GNC setup.
GNC setup, on.
And again, as you have seen, they're working through some engine configs because we are back into the countdown. T-minus 25 minutes or so and counting. Our new T0 is 10:04 p.m. Pacific time or 6:04 a.m. UTC. And the countdown is proceeding. Carolina, what are we doing right now in the countdown?
Sure. So the next step in the countdown is we're going to spin up the pumps of the first stage engine. It's one of our final checks, and we're well on our way to our T0 time in just 24 minutes.
And we're going to keep listening into the countdown net as those milestones get hit. You can hear the mission controllers and the backroom engineers working through all the final preparations for launch, so we'll listen into that. We might have a little bit of time for Q&A, so if you have more questions, please throw them in the chat. We might come back to those in a little bit, but right now let's focus in on the countdown as it progresses. Again, new teaser of 10:04 p.m. Pacific time, 6:04 UTC.
Okay, so some glitch happened. Can you guys hear me? I don't know. For some time, this is not possible for me to know whether I am able to get you guys. Okay. So I was saying, first of all, we have the countdown resumption. That's a great news. And second of all, we will get to see this rocket fly hopefully today, because I am getting a great feeling today for this to launch. So let's hope this launches and we get to see a beautiful launch today. Okay, so do you have any other questions which I can take? Are they venting? Yes, they are venting to, maintain the pressure inside the tank. Okay. Okay, fine. Thank you so much for those things. Okay. Yeah, my timing.
And the countdown net's been a little quiet, but the teams are still progressing through their milestones. And of course, every time I keep saying let's go to countdown, they get quiet. It happens sometimes. But we're at T-minus 23 minutes and counting, and everything proceeding nominally right now. Let's go back into some questions here. And Sam in chat asked, how will Astra manage countdowns and launch schedules with daily launches? It seems like small delays could hold up many launches.
That is a fantastic question, and I very much look forward to having those problems. Those will be good problems to have. But we're focusing tonight on our launch of LV0007, and so you can keep your eyes posted on our future plans by following us on Twitter and checking out our website, astra.com, where we'll be sharing more information about our future plans.
All right. Next question, what are some of the metrics that Astra is expecting to gather from this flight?
Yeah, we get data from all different aspects of our system. Some of the things that we look for is, the health of our launcher, of our ground systems. We also get a ton of data from really every part of the rocket that we're looking to verify, tons and tons of data that our engineering teams will then review after the flight and will use to learn and iterate and make improvements to the vehicle. But the most important objective that we're hoping to achieve tonight is reaching orbit, and again simulating that signal for payload deployment for the mass simulator that is our payload for this evening's mission.
Speaking of payload, I got a question in chat from Brody asking if the white area on top is a larger fairing or just the very tip. Can you just tell us what we're looking at right now? Because there's tanks, there's frosty tanks, and there's the white part up top. What are all these different components?
Sure, and maybe we can bring up. We have a graphic to show the different parts of the vehicle that we can maybe bring up, but.
Okay, so
Bottom of the first stage, and then we'll work our way up the rocket. So first, you can see we have our first stage Delphin engines. Those are electric pump-fed engines that each produce 6,500 pounds of thrust. You can see sort of 3 of them peeking out from under the engine bay, but we do have 5 of them on the first stage. And then they are attached to that engine bay segment, which contains the pumps, the electronics, and the plumbing needed to run those engines. Moving up to the right is the first stage, that is the largest segment of the vehicle, and that is the propellant that powers those Delphin engines. Both stages are full of liquid oxygen and RPX, which is essentially kerosene. And then the kind of cone-shaped section. That's the inner stage. That contains a lot of the avionics of the vehicle, and also is where the nozzle extension of the upper stage ether engine sort of fits in snugly. And then looking to the right, the upper stage, that sort of dark triangle shape, that's the bottom portion of the upper stage ether engine, which produces 740 pounds of thrust. It's a pressure-fed engine, and there is one of those on the upper stage, and you can see the two spherical tanks on the upper stage that are, again, liquid oxygen and RPX, with that payload adapter plate on top. And then finally, the two halves that you see above and below the upper stage, those are the fairings, which are in two halves, which come apart in order to install that payload on top of the upper stage.
And so those are all the different components, and then when it gets all fueled up, we have this extra kind of confusing bit because it gets frosty near the top of the first stage, and that's the liquid oxygen tank, right?
Right, that's right. So you can see, now if we go from the top, you can see the fairing is kind of that curved upper portion that has the that triangle sticker, that's the Space Force logo, and then the portion that has the star, the Astra logo, that's the inner stage, that cone-shaped portion, and then the part that has kind of what, the steam and the ice on it, that's the top portion of the first stage. So you can see that the first stage is really the majority of the length of the rocket.
And of course, the top portions are the only painted versions. We got that nice bare aluminum down the side of the first stage engine, which of course gets covered up in frost. You might not even be able to tell once it's fully fueled. But the reason that not the whole first stage is like this, because only the liquid oxygen gets cold enough to condense the air around it. The kerosene's at ambient temperatures, right?
Yes, that's right. So the liquid oxygen is very, very cold, and what you're seeing is that ice forming on the outside, kind of similar to the condensation forming if you're having a very cold drink on a hot day. So that's the ambient air around it condensing and forming a thin layer of ice that does tend to fall off as the rocket proceeds through its trajectory.
And then what are all these vapors that we're seeing? We're seeing some around the rocket, and also a bunch from the ground equipment around the rocket. What's that?
Yeah, so those are vents to make sure that we're keeping the propellants at the appropriate temperatures, pressures, making sure that everything remains nice and full, and then the sort of steam that you may see coming off the rocket, that's just kind of that condensation on the outside of the rocket.
We are coming up at the point of the countdown at T-minus 17 minutes and counting here. We're coming up on the water test. We'll see the groundwater deluge test. Now it should be pretty visible. So let's go ahead and listen into the countdown net and listen into the pad as that test comes underway.
Okay, guys, we are right now just under 17 minutes, and we can see those water deluge test. You can see those water stream coming out of the rocket.
Tango, close water valve 100.
Water valve 100 closed.
Water valve 104 closed, please.
104 closed.
Thank you. Good water test. GNC also confirms good on
So
winds.
we are going for a liftoff, guys. Okay, this is happening after so long.
And as you just saw, we had that water deluge test, so the team's continuing to work through the countdown, and everything appears nominal for an on-time liftoff. Again, the T0 is currently targeted for 10:04 p.m. Pacific time. That's just over 16 minutes from now. And we're now getting close to entering the terminal count, I believe is our next milestone, right, Carolina?
That's right. So that's at our T-minus 15-minute mark is terminal count, which is really our final checks of the vehicle. And we can listen in. We'll have a go, no-go poll very shortly to proceed into tank pressurization and launch.
Let's go ahead and listen back into the countdown as the Astra teams get into terminal count.
GNC self-test. GNC call out upon completion with result.
GNC self-test started.
So we'll have to hear the go, no-go poll, which we didn't hear the last time, and it resulted into a scrub. So let's hope we get to hear that, and that would be our final go for the liftoff, hopefully. Let's see. We are T minus 15 minutes after a day long wait, and after so long today also, we are finally 15 minutes away from this beautiful rocket to lift off to the skies and beyond.
Self-test is passed.
Copy.
And the test has passed.
FTS, confirm that the FTS is still enabled and nominal in the vehicle.
The FTS is enabled and nominal.
Tango in fuel 4 operate, please toggle full
Fuel for operate, full,
and
on,
fast.
fast, on.
Please let me know when you're ready to inspect the launch machine and set a new UTC T0 time.
In work.
Okay, so are we going in for another hold?
Good to set time.
What? Okay, let's see.
Tango, I'd like you to set a new UTC T0 time of hours 6,
Hours 6,
minutes 4,
minutes 4,
seconds 0.
seconds 0.
Please save and commit.
Changes committed.
Okay.
All right, we are into the terminal count now. Less than 14 minutes to go. Let's give a brief overview of what today's launch will look like, Carolina.
Sure. A few seconds before liftoff, we will light the 5 first-stage Dolphin engines, and the system will run checks to make sure that everything is nominal. If that looks good, at T0 seconds, we will release the hold-down release mechanisms for liftoff. A few seconds later, the vehicle will begin its pitch over to continue its trajectory. And after that, the next objective is max Q at 1 minute and 10 seconds after launch, a very significant objective. That is the point of maximum aerodynamic pressure on the vehicle. 2 minutes and 50 seconds into the flight, we'll have main engine cutoff, or MECO, and then a few things happen in pretty quick succession. The fairings will separate, and then 5 seconds later, the first stage and the upper stage will separate from each other. And the upper stage ether engine will light at 3 minutes and 5 seconds. It will run for a little over 5 minutes until we have second engine cutoff, or SECO, at 8 minutes and 30 seconds. And then at 8 minutes and 40 seconds, we will have the payload deployment signal. Again, we have a mass simulator as our payload on this mission. We will not be deploying it, but we will send that signal to simulate our deployment. And if we will have achieved all of those steps, we will reach orbit, and we will be very happy with the outcome of this evening's test flight.
Absolutely. Fingers crossed for a very successful test flight. And just over 12 minutes from now, we're going to listen back into the countdown net. They're going through the final steps preceding the go, no-go poll for tonight. And of course, if all systems are polled go, we are into the business end of the countdown. So let's listen in. 12 minutes and counting.
Active.
AV1 managed power systems.
Active.
All flight helium machines.
Helium stack is up.
VB1 first stage power.
First stage power active.
VB1 upper stage power.
Active.
VB1 turn on off PDBs.
Active.
Water 1 water system.
Water 1 water system active.
This time, Tango, I'd like you to activate launch machine.
Launch machine active.
Please toggle lock stopping.
Lock stopping set to true.
Okay, so finally we are here to witness the launch. It's happening. We are past that 12-minute scrub which happened yesterday, and hopefully nothing will happen now. The weather is looking
step
good.
150, this takes us into the hold for tank pressurization and launch. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
Go.
Delphin.
Go.
Ether.
Ethers go.
Odin.
Odin's go.
Inco.
Inco's go.
Ace.
Go.
Launcher.
Launchers go.
Orbit.
Orbit is go.
Booster.
Go.
GNC.
GNC is go.
FAO.
Go.
CDH.
CDH is go.
Tango.
Tango's go.
Safety.
Safety is go.
Flight is go. Tango and AV1 manage polling. Please toggle do only ground polling.
AV1 manage polling. Do only
Okay,
ground polling.
guys,
On.
there you have
Dolphin, are
it.
you ready to load sequences?
We are given go for
Tango, are
the
you ready?
launch.
Tango standing by.
And
Go
now
ahead, Dolphin.
we just need to wait for around 10 minutes and then we will witness this beautiful rocket to lift off, and hopefully this time it will not go sideways and it will just go straight up and reach the orbit. That's what we want, right? And again repeating, guys, this is a test flight, so things may go wrong, so keep that in mind.
Engine Bravo is 822 Victor 2.
Engine Bravo 822 Victor 2 slot 0. Good load.
Engine Charlie is 823 Victor 2.
Engine Charlie 823 Victor 2 slot 0 loaded.
Engine Delta is 824 Victor 2.
Engine Delta 824 Victor 2 slot 0. Good load.
And Engine Echo is 825 Victor 2.
Engine Echo 825 Victor 2 slot 0 loaded. Successful load.
Astra's gonna call a hold right now.
Oh, come on. No.
RCO copies. We have a hold.
Let's hope it's not a scrub. Wait, I don't. Not good. Hold. Don't know what caused that, but now there are actually high chances of this getting scrubbed today also, because whatever
As you
caused
see, we're
that
at 8 minutes and
hold
38 seconds and holding now. A hold has been called, Carolina.
is
Yeah, as
in the
you
terminal
can see,
countdown.
there appears to be a valve stuck open near the base of the vehicle. It's one of our ground side valves that the team is working to cycle and get that fixed. If we do resolve the issue quickly, which we hopefully will be able to resolve, then we would recycle the clock at T-minus 15 minutes with a new T0 time. So we'll provide some updates as soon as we have more information.
Okay.
But again, we are in a hold.
So
Are in a hold, and we
there
will
you
also
go.
share a new T0 as soon as we have that information as well. So standing by.
So that I was also thinking this, thing coming out of the rocket, that's not a good sign. So this is just a valve which is opened from a ground support equipment perspective. So it's not a technical delay from the rocket, just a, a ground valve which is stuck open. So let's hope they will be able to resolve this issue. Maybe if they are not, maybe just, vent out all the liquid or whatever they are venting to that valve, right? So there are two ways to resolve it: either just close it somehow, or if you can't, just leak all the fuel or whatever it is getting from, just leak all that from that valve. Okay. So we are right now on hold because of that valve, and I think it's still open because of that valve, which you can see here in the pad also, the smoke coming out of the rocket from below, not from above but below, and that is not a good sign. But that's not coming out of the rocket, and as I say, they have almost completely closed it somehow, so that's a great sign, which means we'll be able to. Okay, they are still looking. I think they are just trying to close. They tried to close it, but still it's since it is a stuck valve, it's not closing properly, so we will have to wait for some time. And since if any human interaction, or what do you say, interfere is required, it would mean that they need to detank the rocket from its fuel, which actually means recycle time of, like, as they said, at T-minus 30 minutes we were given go for the propellant load and at T minus 30 minutes the propellant loading commenced. So maybe a 1 hour delay then. So right now, okay, valve is closed, guys. Valve is closed, which we can see here. That's a great sign.
All right, we are still in a hold. However, those teams have been able to cycle that valve that we were looking at, and it sounds like we're going to be ready to recycle back to that T minus 15 point, the terminal count point, and we'll have a new T0 here shortly.
Yes, that's right. The teams were able to resolve the issue. You don't see any of the sort of cloud that was forming near the base of the vehicle, and we believe we have addressed the issue. So we'll have an updated T0s shortly.
So that's a good
And
news.
again, once we get back into terminal count, the next big milestone is going to be after a couple preliminary steps, there will be the go, no-go poll once again to get back into the final 10 minutes of the count. But they're going to recycle to the hold point of T-minus 15 minutes to actually enter the terminal count. And once we have a new T0, we'll share that.
So this T0 determination is also a thing which they have to really do, because they can't just put a number on it and let's just lift the rocket up at this time. No, that's not how it works. When they try to determine the new T0, they do it by checking the checklist, which they have to do. Means they have like a couple of few tasks which they have to do. So they need to make sure that all the tasks are done properly. So one factor is that. The other factor is they need to again put those numbers into the rocket. I mean, load numbers into the rocket according to the latest weather and the trajectory information, because the earth is also rotating, right? And we have seen that whenever the rocket launches to ISS, there's a like instantaneous launch window of 1 to 5 seconds. So 15-minute delay, which means earth has rotated a lot, and therefore trajectory information also needs to change, and the weather may also have got updated. So those all information needs to get uploaded into the rocket, and once they have, right now what they are doing is try to determine one of the T0 and then try to simulate all the things according to the plan. Once they have a simulation pass, they will load that thing into the rocket and we will see a new T0. So that's how things work. If you are just joining in, guys, we got the hold because there was one valve stuck open in the launch pad. Okay, so yes, now they have resolved that issue. The valve is not open now, and they are just determining the new T0. So we will see and we will get the information as soon as they determine that new T0. And yes, you can see the gate is open, and now there are many more gates which are open, which is good to see, right? They don't want to destroy the launch pad. If that gate was not open at that point of time, we would not have seen the beautiful display of thrust vector control, first of all, and the second of all, that the rocket would have run on the launch pad itself, which would have cost a lot of time as well as lot of money to refurbish the launch pad. Launch pad is also a very costly uh, thing, and it is a thing which is reused, but it's a costly thing, and if it's get destroyed, it takes times to rebuild it, as well as um, takes a lot of money to rebuild it basically. So you don't want that, and that's why they just did not uh, press the flight termination system when the rocket went like sideways. They I don't think so they believed that their thrust vector control will work so very well. At that point of time, everyone, the TVC GNC engineers were all amazed by the work which they have done. I mean, they would have written the code keeping in mind like this would happen at some point of time in the flight and not at the launch pad, right? In the flight, and let's just code it. I know this is a thing which could happen but may not happen, so let's just code it and load that software or algorithm into the rocket. But they they did not know that they will see their beautiful algorithm in work when their uh, rocket is launching with the LV006. Uh, yeah, LV006. So that was a delight for them also. They got the real world data for their algorithms and the control mechanism, which was great.
All right, we are still in that hold, but we are expecting a new T0 shortly. The teams have been able to cycle that valve that we were seeing in the bottom of the launcher there, and we're expecting a new T0 shortly.
Yes, that's right. The teams have resolved the issue, so any moment now we expect to have an updated T0 and resume the countdown.
What we'll hear on the countdown net, which we'll be able to listen into, is them setting that new T0 time, and then the teams will go back into go, no-go polling to proceed with the launch attempt. So standing by for that T0 call from Flight Director Chris Hoffman.
Flight on countdown picking back up. Tango, please let me know when you can deactivate and inspect the launch machine to update our T0.
In work, deactivating launch machine. Inspecting, ready to set a T0.
Hours 6.
Hours 6.
Minutes 16.
Minutes 16.
Seconds 00.
Seconds 00.
Save and commit.
Changes committed.
Then let me know when you're ready to activate.
Ready to activate.
And as you just heard, our new T0 is 10:16 p.m. Pacific time, or 6:16 UTC. The Astra teams are now 9 minutes and 30 seconds left.
Okay, that's a great news. Finally, guys, we are getting.
Go.
We
Red
got
lead.
the new T0
Go.
and
FTS.
okay.
FTS is go.
Dolphin.
Go.
Ether.
Go.
Odin.
Go.
Inco.
Inco's go.
Ace.
Go.
Launcher.
Launchers go.
Orbit.
Go.
Booster.
Go.
GNC.
Go.
FAO.
Go.
CDH.
CH is go.
Tango.
Tango's go.
Safety.
Safety is go.
Flight is go. Tango, confirm that in AV1 managed polling, we are still in ground mode.
We are currently in do both ground and guidance, turning only ground pulling on. Do only ground is set to true.
Dolphin, do you require new sequences?
Sequences have not changed, so we do not need to reload.
Copy. Ether, please provide me with your flight sequence for tonight.
Ether flight sequence 806 Victor 3.
Ether sequence 806 Victor 3. Title all hosses, no bosses. Slot 0 loading.
You just heard the teams have pulled go for launch. We're at T-minus
Successful
8
load.
minutes and counting.
Tango and AV1 managed polling, please toggle do both ground and guidance.
Okay, so we are go for the launch, guys. That's a great news. We are picking up the count. We are T-minus 8 minutes.
Confirm GSE igniter
And
system
everything
ready
is
for launch.
looking great. Weather is holding up. The rocket is getting ready for the liftoff, and everything is green right now. Let's hope it stays green and we get to see this
FTS, issue logic command
rocket
to you,
launch
verify
to the
passage,
sky
speed,
and
knock.
beyond.
And work.
One
Launch
minute and
enabled,
30
issued
seconds.
and received on both AFTUs.
Copy.
do have like multiple camera angles going on here, which is always great, right? So let's see how the things would look like when this rocket will launch at the night time, and let's hope this reaches orbit this time, which would be a great achievement for them.
Tango, at this time, verify that the vehicle is ready for launch aside from tank pressures.
Blue lines are met. Looks good.
If you're just joining us, we're at 6.5 minutes and counting. Everything on track for a liftoff at 10:16 p.m. Pacific time. Teams have pulled go for launch and are now into the final steps of the countdown.
Final steps in the countdown. T minus 6
RCO
minutes.
flight on countdown. At this time, I am looking for final range green and launch authorization for this evening.
This is RCO. Range is green. You are authorized to launch.
There you go, guys. We are
You
going
just
for
heard
a
the
launch
range
today.
is authorized to go for launch. Range green.
Final preparations are going on. Things are looking great on the launch
Tango, at
pad.
this time in the launch machine, I would like you to enable launch.
Launch enabled.
Minus 5 minutes and 20 seconds. Just venting off those pipes, clearing those fuel lines. That's what you are seeing right now. Excessive venting. We'll also see the water suppression system test at T minus 3 minutes or so, which would be great, I guess.
Now T-minus 5 minutes and counting. Again, everything on track and nominal for liftoff.
T minus 4 minutes and 30 seconds. Guys, this is happening. Okay. I'm getting excited because what we saw the last time. Does that mean we have something interesting in store for us today also? Let's see.
RCO flight on countdown. Verify range. Will be recording telemetry at liftoff.
This is RCO. I can confirm range is recording telemetry.
Thank you. 4 minutes.
Okay, so everyone in the Astra team as well as from left space nerds like me
Reminder to
are
control room, if you require RF data, please be prepared to switch over your Grafana pages at liftoff.
very excited for this vehicle to lift off today. So let's sit back and relax and see this beauty fly to the sky.
FSO flight on countdown. Please be prepared to issue option command at T+162, calling out at event.
Roger, 162.
Coming up on 3 minutes and counting. Again, we are 3 minutes away from liftoff.
Three
This
minutes.
is Astra's 4th orbital launch attempt for LV, and this is LV0007 into the business end of the countdown. Let's listen in for the final steps and liftoff.
The venting is decreased
Reminder to
now.
all that any 3-word hold from here on out is an immediate abort regardless of source. Tango, please turn off igniter heaters.
Igniter heaters coming off.
Okay,
Current
guys.
response.
Finally. I'm so excited.
FTS, you are good to send master enable and watchdog on AFTU.
And work.
Minus 2 minutes.
2 minutes.
Master enable and watchdog sent and received on both AFTUs.
Copy.
T-minus 145, all systems nominal at this time.
Okay, this is very cool. Minus 1 minute and 30 seconds.
90 seconds.
During launch, we'll have live telemetry
Ace,
on the
this
bottom
time
right
you
of your
can
screen.
start PSD recordings.
Done.
And start downrange recording.
Also done.
T minus 1 minute, guys. Whoa, this is happening. Looks great. Did that.
60 seconds, vehicle's on internal control.
Vehicle is on internal power. Okay. Finally.
First stage LOX tank pressurizing.
Fingers crossed.
First stage fuel tank pressing.
Let's get the show started. $30.
30 seconds.
Minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11,
Water on.
10.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
First motion.
It's running. First motion.
Whoa!
Vehicle is clear the tower.
Whoa, man, this looks so good.
LV0007 has cleared the pad and is on its way to space. Our next
This
objective
looks so
is
good
next
today.
here. On the left side of your screen, you'll see the progress of the vehicle through our mission milestones. And you can see velocity and altitude.
Velocity 19 meters.
LV0007 ascending through some clouds over Kodiak, now looking at onboard views from the rocket.
90 meters, 44 meters per second, increasing
Vehicles
rapidly.
just passed 50 meters per second, 3 kilometers in altitude.
Vehicle's tracking downrange.
And the vehicle's just started pitching downrange.
Which is always great. The onboard cameras are looking good. The plume expansion is looking good, which is not triangular. It's more spherical this time, which is
T plus
what we
1 minute.
want.
The vehicle is now through maximum aerodynamic pressure, the point of maximum aerodynamic stress on the vehicle. Next up is main engine cutoff, or MECO, at just about T plus 2 minutes and 30 seconds.
I don't know what's the thing with the velocity though. Let's hope that is correct because it's very
Vehicle now
low.
over 300 meters per second at an altitude of 12 kilometers. And everything appears to be nominal at this time.
Although increasing rapidly. 538.
Vehicle's on track downrange.
Everything, yeah,
We're
the plume
confirming that the vehicle
expansion.
is on track downrange and all systems appear nominal, nearly at the end of our first stage flight.
And you can see as the rocket ascends through the thinner parts of the atmosphere, you can see the engine plume expanding. That's a gorgeous shot from that onboard camera.
Whoa. So now 1 kilometers a second has been touched. Things are looking great. The MECO is coming up very shortly. The altitude is
coming up on main
just
engine cutoff,
39
just about 20
kilometers.
seconds from now.
The altitude is 44 kilometers. 47, which is like
Good signal strength. Vehicle's tracking downrange.
per the atmosphere. Everything is looking great. So good to see these companies also progressing to space. Wow. 3
Option,
kilometers
sir.
a second.
Confirmed. Option as received.
Okay. And
And
Miko.
we've just heard the
Miko.
call out for main engine cutoff.
Fairing separation
There we
confirmed.
have fairing separation and a successful stage
Whoa.
separation.
Look at those gorgeous onboard views.
And start.
And
We
that
have ignition of the upper stage ether engine. T plus 3 minutes, 22 seconds and counting. The upper stage now taking control of the flight. Teams are here in Alameda
Dude.
very excited, and rightfully so. 3.5 minutes in the flight, everything on track so far.
This is
Again, this
looking
burn lasts
so
just
great.
over 5 minutes. We would expect second engine cutoff at T plus 8 minutes and 30 seconds. And this second stage's job is to get the payload and itself all the way up to orbital velocity.
we're looking for the altitude of 500 kilometers for this mission.
Currently passing 200 kilometers already into space, but of course you got to get that extra velocity and altitude to stay in orbit. That's the big ticket. But again, everything
Fingers
nominal at
crossed
this
now.
time.
Everything is looking great. This is a pressure fed engine.
Looking at our mission control team, still holding on to the controls. And here we have the crew of folks at Astra who very happy with the outcome of today's flight so far. And we are still holding on for that second engine cutoff.
Just look at that velocity as well as altitude, and if it is above 8 kilometers a second, you can say they have reached the orbit. So let's see. Well, means 7 to 8 or above 8. Let's see what happens. Right now things are looking good. No worries with
Everything continues to be
anything.
nominal. T plus 5 minutes now. Vehicle now over 300 kilometers in altitude, 4.5 kilometers per second of speed.
And let me just tell you guys, this engine produces just
And we want to give a
around
shout out as well at this point to Thibault Lassalle for our graphics this evening. We are very happy to see our mission progressing with the graphics that we have, and continuing to watch that beautiful sight of the first stage, or excuse me, the upper stage ether engine taking us to orbit.
You see that actually engine bell glowing from the heat of the rocket operating, and of course the little bit of plume in the night sky south of Kodiak. Again, this mission going to an 86-degree inclination, so a nearly polar orbit, flying pretty much straight south from Kodiak.
Okay, so T plus 5 minutes, and yes, this produces around 3.2 kilonewtons of thrust, so it's not that great, and that's why the velocity
T plus
is
6 minutes, about 2.5
slowly,
minutes left in
slowly
this upper
climbing.
stage burn, and everything on track so far.
5 kilometers a second, 390
So
altitude.
we've got a little bit over 2 minutes remaining in this upper stage flight. We're just at 400 kilometers, which again we're getting less than, we're now less than 100 kilometers for our target orbit.
Everyone is just waiting for that
Vehicle now traveling
orbital.
5.5 kilometers every second and an altitude of 434 kilometers. Again, that live telemetry is in the bottom right hand of your screen. And on the left, you're seeing the different milestones. We're into second stage flight at T plus 7 minutes, about a minute and a half left to go. Again, there is no deployed payload on board the upper stage, so as long as this second stage burn completes successfully, there will be a simulated deployment signal, and then that's it. The main objective is to reach orbit, and we're just over a minute away from that happening.
Mission control is looking happy right now, but let's see whether it is able to cross that 7 kilometer per second mark.
And T plus 7
kilometer.
minutes 30 seconds, all on track.
They are just waiting because previously they fell short
Big
of
shout
like
out to the teams here in Alameda
400 to
watching
600
closely.
meters a second. Let's hope they don't fell short now.
Engine pressure still looking good.
Okay, things are looking great.
T plus 8 minutes in the flight, all systems nominal. Second stage burn coming to a close here shortly.
I'm crossing my fingers because let's see. Velocity, please climb up fast. There you go, 7 kilometers a second. Now we should be get around 8 kilometers per second, close to 8 kilometers a second. Let's see, when do we get that? Is rapidly climbing up. For 97 kilometers. And we have cut off. They reach the orbit.
And there you have it, orbital insertion, second engine cutoff, and Astra's LV0007 has successfully reached orbit. There is a new orbital rocket.
Okay, so they have reached
And there
the
is
orbit.
the view of the simulated payload, the mass simulator up top. Mission success. Just a 9-minute trip to orbit, and Astra is in orbit.
And I can speak for the team. Everyone is hugging and cheering here. We are absolutely bursting with pride at LV0007, lucky number 7. This represents a huge, huge step in our mission to improve life on Earth from space.
Astra's 4th orbital launch attempt, LV0007, the first one to achieve orbit, a successful test flight and demonstration, paving the way for future customer missions. Very exciting to see here. Absolutely gorgeous views all the way. And a very happy team here in Alameda. I'm sure a very happy team up in Kodiak as well. There is your flight path right down the middle.
Wow, well timed. Yeah, the stock market.
I want to say to everyone who's joined us, thank you so much for sticking with us. And again, to confirm, we have accomplished our main objective for today. LV0007 has reached orbit with its test payload. I'm so proud of our incredible milestone for Astra and all of our partners, a major step forward in our mission. And we will continue to provide innovative, low-cost, and nimble launch capabilities riding on this evening's success.
From the NASA Spaceflight team, this is Thomas Burkhardt, News Director. I just want to say a big thank you to Astra for trusting NASA Spaceflight with this broadcast, being able to see firsthand the first successful orbital launch of a new company's rocket is just something incredible. It's incredible to be here with the teams. Just from our perspective, this is just so cool to experience, and a huge congratulations, Carolina, to you and the entire Astra team on this accomplishment. It is no small feat. And of course, the iterative path to orbit, it took, you learned a whole lot on the way there, but this has just been so cool to watch. Thank you so much for partnering with us to do this.
Thank you so much, Thomas. Let's go celebrate.
All right, everyone, thank you so much for watching. This has been super cool. Again, Astra has successfully reached orbit with LV0007. And we are going to stick around for just a couple seconds here. I believe we're going to have a quick visitor here. Mr. Chris Kemp, hop on comms with us really quick.
Hey guys, how's it going?
He's the CEO
It's going
of
well.
Astra.
Of course, Chris Kemp, CEO of Astra. Chris, congratulations to you and the team. How are you feeling right now?
Absolutely incredible. The team's worked so hard on this for so many years, and this just really seeing iteration after iteration, failure after failure lead to success. Everyone is just incredibly passionate about corks are flying. Yeah, I mean, it's an incredibly hard thing to do. Continuing to do it is incredibly hard. We have rocket serial number 8, 9, 10 in production, so we're just getting started.
Absolutely. Chris, thank
Yeah.
you so
Thank
much
you
for
guys so
allowing
much.
us to be involved in this, and best of luck going forward, and go celebrate.
Indeed. Thank you guys. Bye.
Again, everyone, thank you so much for joining us. Carolina, Chris, the entire Astra team, the entire NASA Spaceflight team, and most of all, everyone watching at home. Thanks for tuning in. Big thank you to Astra and partnering with us to help make this broadcast happen. Couldn't have done it without you. And NASA Spaceflight and Astra, looking forward to future Astra launches. Stay tuned for future spaceflight coverage on NASA Spaceflight. With this mission success, we're going to go ahead and wrap it up and sign off for tonight. Thank you all so much for watching, and we'll see you next time.
Whoa, whoa, whoa. That was freaking awesome. I must say that. I mean, guys, they finally reached the orbit, and whoa, the means the replay. Let's just see the replay also. I mean, their liftoff also looked so good. Yeah, this has to be the best second stage cam. We were able to see those rocket actually coming to life from there, right? Wow. The stock has risen, and let's see the replay once again, because why not?
First stage fuel tank pressing. "30 seconds.
It was great to see this rocket actually lift off from the pad.
Water on. 10, 9, 8, 7, 6, 5, 4.
And that sound. What? I think there is some glitch in the YouTube itself.
First motion.
This looks so good. The liftoff was so good. And I think there is some glitch in the YouTube for some reason. No worries. But guys, finally they made it to the orbit, and that's what you call perseverance. Literally, you need to just try. You will keep failing. That's a good life lesson also. You will keep failing. That's not a problem. That's actually a part of life. But you can see that that's a part of your success story and success ladder. Whenever you fail, just think you are close to getting success. Okay? So don't feel demotivated. This is a thing which I follow myself. Whenever I fail, I just feel that I am very close to success. I'm getting close to success now. So failure is a part of life, and don't get demotivated from it. Just see it as an opportunity, because that simply means you are getting close to success. And best example is Astra here right now. They reached, they in the third attempt they were able to in the fifth attempt they were able, or yeah, third, this was the fourth attempt. In the second attempt they were able to get to the orbit, but they fell short of for the orbital velocity because of some fuel mixture ratio problem. They fixed that, and then the other launch had a problem with that fuel lines, which caused the red of the vehicle, right? So, but finally, after so many years of just testing, making, and iterating, and just, playing around with the rockets, they were able to finally get into the orbital class family. And we just saw a beautiful liftoff and the beautiful um, reach to the space. Was so damn cool. I mean, liftoff is phenomenal. I can just see this all day. This liftoff is like, I can see this all day, and I don't know why, but this is the best liftoff I've ever seen, at least for in the video. So this is a small rocket, na? Then we actually get everything into perspective, and all those things we can see properly. So yes, wow, that was great. And I hope Iron Glue Gaming, you must have got your birthday gift, and Mr. Tori Bruno also had his birthday yesterday, I guess. So you and have had a same day birthday, so that's great, right? And great coverage, and finally good liftoff to the space, and finally they are to the space. Okay, so congratulations, Astra. Yes, Shashank. They were so happy, which they actually deserve also, right? I mean, they did their homework, as well as the hard work, as well as the thing which is required for the rocket science, which is required properly in rocket engineering. They did all of that properly this time, and they got the fruit. They were able to reach the orbit, and now we have a competitor for Rocket Lab. I won't say a proper competitor, but at least a competitor is there. They have reached the orbit, and it would be interesting to see whether the next launch will also be from the Department of Defense, and will that also be a mass simulator, or they would start putting some payloads, actual payloads to this rocket. We'll have to wait and see. And as Chris Camp said, the rockets number 8, 9, 10 is already in production. Just saw the liftoff of rocket number 7, and 8, 9, 10 is already in production, which means they are actually looking in for a rapid launch of these vehicles. So as they said, making of one rocket takes around 1 month or so. So maybe next month we'll be able to see another launch. We'll have to wait and see. Maybe they will just review some of the data. They have got the success, but data review is always good, because sometimes you get success, but there are some faults in your way. So you need to rectify that. Otherwise, that could prove to be fatal in some other launch, right? So data review is always very necessary. अरे भाई भाई भाई, congrats भाई. सही है. अब करो अच्छे से और हो जाएगा बढ़िया, शशांक. Congrats भाई. Okay then, guys, I hope I did the justice today, and you were able to enjoy properly the liftoff as well as the launch. And now the next mission coming up is the DART mission from SpaceX, and that would be of NASA. So in 3 days of time, on 24th of November, you will see the DART mission, which is very cool to watch. So let's hope we get a success there also, and I'll be there to explain you all the things that you know for the DART mission also. But yeah, bye bye. सही है, NIT Warangal या फिर IIT Patna, both are good. Basically, if you are actually looking in for, maybe just prefer stream, then you have any favorite stream, then just prefer that and accordingly select. Because I don't think so NIT में तुम्हें घर जाने देते हैं, रोज भी रहते हो. IIT में भी you just need to, in weekends you can go home, but you have to remain in hostel. I think so, that is the rule. Okay. So I guess, guys, so let's just um, say goodbye for today, and get carry on with our work, because this was a successful liftoff today, and we'll come back with more launches. And the next one is my favorite coming up, the DART mission, the type of planetary defense system which we are trying to make, which is so cool. I'll explain you everything about it, and we will meet at that point of time. So thank you so much for tuning in, guys. I hope you enjoyed the stream. If you did, just hit that subscribe button, hit that like button, and don't forget to come up again at on 24th November. Thank you so much. Guys, until then, this is Pian Shiroila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.